Okay, so let's do problem 4-4, and I have it here, and we're supposed to be finding the moment about point A of each of the three forces acting on the beam. We have three forces, 375, F2 is 500 pounds, and F3 is 160 pounds acting at 30 degrees this direction. So given the beam right here, I drew it a little bigger, this 375 pound force is going to create a clockwise moment around A. All right, this 500 pound force, which is kind of at an angle here, the vertical component of this force, the vertical component is going to create a clockwise moment around A. So it's going to want to spin this beam around clockwise. And it also has a horizontal component here, this little horizontal component. But the horizontal component, if you look, is actually pointed directly at A. So it's going to cause, it's not going to want to cause any rotation around A. So we don't need to account for that horizontal component of this force. F3, I think, is the trickiest one to do because we have this 160 pound force at 30 degrees. It's going to create a clockwise moment. The downward component of this force is going to create a clockwise moment around A. And we also have this horizontal component here of this force. And the horizontal component is going to want to create a counterclockwise moment around A. So this is the tricky one because we need to take into account both the vertical and horizontal components of this force creating moments around A. So let's get started with this. Okay, so let's start our analysis. And we'll start with the moment that F1 creates around point A. And how we usually call this, we call positive the counterclockwise direction. All right, so I'm going to use that sign convention. So this 375 pound force is going to want to create a clockwise motion. So that's opposite to how we drew our sign convention. So that is actually going to be negative now, right? Because it's opposite of our positive direction. So that's 375 times the perpendicular distance away, which is 8. Okay, and that comes out to 3,000. Let's put a negative there. Don't forget the negative. Negative 3,000 pound feet. Which, if we remember that 1,000 pounds is 1 kip, we can write this just as 3 kip feet clockwise. So we got rid of the negative by putting the clockwise notation at the end there. So that's one of our answers here. All right, the same thing, let's do the same thing for F2. So we have the moment of force 2 around point A, and we'll use the same sign convention, counterclockwise being positive. Now, we only need to account for the vertical component here, the vertical component. And so, and this is all, the vertical component is going to want to create a clockwise rotation around point A as well. So we have, so that's opposite of our sign convention. So again, we need to add that negative there. So we have negative 500. But it's not the full 500. It's just the downward component of that. So if we look at this triangle, we see that the downward component is 4, and the hypotenuse is 5. So there we have the force component acting downward, and then don't forget to multiply it by the perpendicular distance it is away. So that's 8 plus 6, which is 14. And that comes out to negative 5,600 pound feet. And then again, since it's negative, we know it is opposite of our sign convention. So that is 5.6 kip feet clockwise. And that's our second answer. And then for our third, we would do the moment that F3 creates around point A. And again, we'll have the positive sign convention going this way. So the vertical component here is going to want to create a clockwise rotation around A. So that is negative. So we have negative 160. And then we need the vertical component, which should be the cosine of 30 degrees. So negative 160 cosine 30 degrees will be the component here, the downward component. And then we need to multiply it by the perpendicular distance it is away. So for the downward force, that is 8 plus 6 plus 5, and that should be 19. Okay. And lastly, we need to take into account the horizontal component of this force. All right, and the horizontal component is actually going to create a counterclockwise rotation around A, which is then going to be positive, so positive 160. And then we need the horizontal component is then sine of 30 degrees. And then we need to multiply by the perpendicular distance it is away. So if the horizontal component is going this direction, all right, it is this distance here, which is 0.5. So we'll multiply that by 0.5 here. All right, so let me calculate this quick. So we have negative 160 cosine 30 times 19 plus 160 sine 30 degrees times 0.5, right? And what we come up with there is negative 2,592.75 pound-feet, which is then equal to 2.59 kip feet clockwise. And that is our answer for the third force. And that is it.